We are live, Pak.
I can start now?
Yes.
Okay, thank you. Good afternoon, selamat sore, selamat siang, and also good morning to participants, speakers who are in different time zone, particularly for our speakers who are based in Europe. I'm Saud Sagala, Senior Fellow in Resilience Development Initiative, and also the team leader for the working package 3 of Digital Global Biogas Corporation. We are from Resilience Development Initiative. We welcome everyone to join this webinar. We would like to share to you on the project Digital Global Biogas Corporation that we have. I will explain more detail about this. We'll have moderator Dr. Yudha Prambudia, who is also RDI Senior Fellow, and then 2 speakers from Europe, Frank Hoffman, and also Angela Sainz, who are based in Germany and also in Belgium. Other than this speaker and moderator, we will have also Dr. Abdul Holly from BPPT, Indonesia Research and Technology Agency. So I will not speak too much about this introduction. I will welcome all the speakers to start later after I will explain about what DiBiCoo is. May I ask the to open with the slides? Yeah, our team consists of myself, Saud Sagala, there is Elizabeth Rianawati, Iksan Luxmanto, and also there are other team members involved, which we cannot write, of course, everyone here, but we are the DiBiCoo project team for the RDI. Next one, please. So what is DiBiCoo? In here, we also put the text or the slides in Bahasa Indonesia so that others can read this and understand this quicker. But the DiBiCoo is a digital biogas cooperative that is aimed to establish biogas market between Europe and also developing country. And with our aim is to increase the share of renewable energies both in Europe and also in target country. We aim to create business collaboration and introduce European technologies to Latin America, Africa, and Southeast Asia. So these are the countries where the and also continents where the collaboration is taking place. It is trying to help to mitigate the greenhouse gas emissions and to increase the share of global renewable energy generation, and also to share knowledge, foster common learning, and also experience sharing platform between particularly Indonesia and Europe. And lastly, what is important, as also stated in the UN Sustainable Development Goals, is related to Goal 7, affordable and clean energy, and the other is Goal 9 on innovation infrastructures. Next one. What is DiBiCoo? DiBiCoo will cover a number of points such as business engagement or market development initiative. The purpose is to bridge biogas stakeholders and implementers in the field, especially with the technology providers, developers, and also financial institutions. It is a platform that will serve as a marketplace and a knowledge hub, and it will support the creation of a large-scale business case pilot projects for developers and also suppliers. It will provide needed capacity building and training opportunities and linkage to other projects. And what is not under or covered by DiBiCoo is that it is not involved in the construction of biogas projects, but work to analyze, synthesize, and to develop country-specific technology solutions in importing countries and support up to pre-feasibility stage. It is not a fund or financial support program, but covers expenses for capacity development and coordination. Next. There are some countries involved, as you can see in this slide or map, that we have European biogas industry, and then we have Argentine, Ghana, Ethiopia, Indonesia, and also South Africa. So it's spread over in different places of the globe, and then it's aiming to a growing market for renewable energy and the biogas. Next. There are two main mechanisms that we would like to explain to you about the DiBiCoo. That first one is about the digital platform. The digital platform is the DiBiCoo online information system. It's being developed, soon to be launched, and also it is a tool for networking and matchmaking between industry players from Europe and target countries for biogas technologies. It aims to involve or inform users on global good practices, facilitate potential industrial partnerships, obtain first-class consulting services which act as a database, and finally, it will allow access to global industry information and linkage with existing similar projects from 13 countries. The type of information that we share in this digital platform is that a database of industrial actors, companies, information on available technologies, advisory and networking services, and semi-automated guided solutions. So you expect that people can join and also gain selected access to the prototype. The second one that we would like to also involve you is on the demo cases. The DiBiCoo demo cases welcomes project ideas and local partners interested in the technical, economic, and social development of Indonesia biogas industry. So there are some key technical informations involved, such as target groups, stakeholders with access to organic waste, material from agriculture, sewage, management, livestock farming, industrial processes, food, beverage, etc. The focus is on large capacity biogas plants of about 1 megawatt installed capacity. Next. For the demo case participants, there are free of charge support provided, such as the technical concept of the development of technical concept of the biogas. There is document and self-verification of feasibility. There is impact assessment, and then financially viable business model development, training know-how answer, and also direct link to domestic and international key stakeholders. Next. So we would like to welcome you. This is the final slide, and to close this opening, that there will be demo case registration will close on 31st July 2020 with the following link that you can see on your screen, or you can contact us with the more information on the DiBiCoo website. Our contact from RDI is Andreas Dwi Putra. You have the phone number and also the email to contact with. Thank you very much for your participation, and we would like to see you to be involved in the DiBiCoo activity. And with this, I would like to pass this to Dr. Yudha Prambudia, who will moderate us in the all the session. Thank you very much. Over to you.
Thank you, Pak Saud. And welcome everybody to the webinar. We are grateful today that we are all in good health amid the COVID-19 pandemic. And also we are grateful that we have three important speakers with us today to discuss on the topics mentioned by Pak Saud previously. We have among us now Angela Sainz of the European Biogas Association. We have also Bapak Abdul Holly, the chairman of Asosiasi Biogas Indonesia, and also we have Frank Hoffman of German Biogas Associations. The webinar today will be divided into two sessions. And in the first sessions, we will have a brief explanation of EBA, European Biogas Association, and then followed by Bapak Abdul presenting his experience in biogas implementation in Indonesia. And in the second session, Frank will present his experience and introduce German biogas technology. And then lastly, the question and answer session will be provided at the end of each of the sessions. So without further ado, let's just move on to the first session with Angela Sainz. Let me introduce Angela first. Angela is the communication manager of EPA, European Biogas Association. She is responsible for the external and internal communication activities and projects of the association. She has spent the last 8 years of her professional career in energy field and holds postgraduate studies in communication and EU policies, and also a master's degree in journalism from the University of Valencia, Spain. And with that, I invite Angela Sainz. To you, Angela.
Hello. Good morning from Europe and good afternoon to the people in Indonesia. I will maybe just make a short introduction on the European context and what is happening here in Europe. And then I will also explain a little bit what is EBA and what we do in DiBiCoo, what is our role in DiBiCoo. Well, concerning the European context, it is important to say that the European Union has set a target to reach carbon neutrality by 2050. And this has been important to develop policies that support the development of renewable energies, including biogas and biomethane. In Europe, our industry is already producing 171 terawatt hours of biogas and 23 terawatt hours of biomethane. And we have over 18,000 biogas installations and 729 biomethane plants in Europe. So, well, the industry is developing, and it is, well, we are in the process now of scaling up the industry. Renewable energies, in this case renewable gases, are very useful to produce heat, power, can be used as transport fuel as well, for instance, in heavy-duty vehicles such as trucks. And it has also other applications. It can, for instance, be used in agriculture, because the biogas produces a byproduct that is called digestate that can be used as biofertilizer. So as you can see, it is not only about producing energy, it's about also producing positive benefits for our society and for our environment. And in this context, what EVA does, well, EVA advocate for the recognition of biogas, biomethane, and all other renewable gases as sustainable, renewable energy that can provide multiple socioeconomic benefits and environmental benefits. And in our association, we have 3 different teams. The main team is the policy team that is working to promote the development of European policies that support the development of the industry. We have also a technical team that is more focused on research and the collection of data across Europe on what is the situation and how the situation can develop in the future. And then we have the communication team that is supporting the promotion of biogas and biomethane and raising awareness on what these renewable gases are and what benefits can provide to our society. In terms of what EVA is doing in DiBiCoo, well, as you can imagine, of course, we provide our policy expertise because, well, we are closely monitoring the European context and working on the policies that can be developed to promote the scale up of the industry. And we think that the example of what is being done in Europe can also be helpful for other countries to develop their own biogas and biomethane industry. And we have also a very important network of stakeholders across Europe We work, of course, closely with policymakers, but not only. We have an important membership network, which covers 28 countries, more or less, in Europe, including 38 national associations and around 96 companies and research institutes. So all these partners are, of course, being informed on what is happening in this project, and if they are interested, they can become, of course, a partner of DiBiCoo. So that's all from my side about this introduction. I will be happy to take any further questions if you have any.
Okay, thank you very much, Angela. And for those attendees who have questions, this question to speakers can be delivered via the Padlet platform, and the webinar team will help the attendees with that. And question will be discussed during the Q&A sessions at the end of these first sessions. So now we will move on to our second speaker, Dr. Abdul Holly. So let me introduce you Dr. Abdul Holly. He is the head of program and budgeting at the Center of Technology of Energy Resources and Chemical Industry under the Agency of the Assessment and Application of Technology, or BPPT, Indonesia. He is also the vice chairman of Asia Pacific Biogas Alliance and also the chairman of Indonesian Biogas Associations, with more than 15 years professional experiences in biogas, from organic waste, wastewater, as well as agricultural waste, including POME, or palm oil meal effluent. He also has a strong educational background with a doctoral degree from the University of Saarland in biochemical engineering. He also has Master of Science from the Technical University of Hamburg on process engineering, and also a bachelor degree from Technical Hochschule Nuremberg on chemical engineering. Both of his diploma and master thesis were on biogas and from organic wastes. So let's just invite Bapak Abdul Holly. Pak Abdul, silakan Pak.
Thank you very much. Good afternoon, everybody from Indonesia and around Asia Pacific, possibly. And good morning for speakers and participants from European countries, from Hoffman and Angela, Sainz. Good morning. Yes, I would like to present about the development and application of biogas technology in Indonesia. I am Muhammad Abdul Holly. I am engineer at the BPT, the Agency of Assessment and Application of Technology under the Ministry for Research and Technology. And I am also vice chairman of Asia Pacific Alliance and chairman of Indonesian Biogas Association. Next. Yeah, next. That was my diploma thesis and master thesis about pretreatment of organic waste via thermopressure hydrolysis. And for my master thesis, I did development of fuzzy logic based control for anaerobic process. And 2016, I visited Germany again for training and tour, biogas tour by IBBK in Southwest Germany. Next. That is some milestones or result our development, research development application of biogas technology at the BPPT, our agency. That's not all, some others, but I have these pictures. The first one is the biogas project to treat the wastewater from slaughterhouse in Cakung, East Jakarta. That was cooperation between Germany and Indonesia, cooperation in many aspects, but yes, environmental aspect of slaughterhouse. We developed together with German partners the composting plant and also biogas plant to treat the wastewater. And I joined this in 2002 after my master thesis, and I came back to Indonesia. And the second one is the biogas plant to treat the wastewater from bioethanol processing. And the next was about the biogas production from organic waste, for example, from restaurant food leftovers or from traditional market, the organic waste from traditional market. And the last 3 years, we have a project in biogas from palm oil mill effluents. Two types we have developed. One is the lagoon, covered lagoon type, and the second one is the CSTA tank reactor type of biogas reactor. Next. Yeah, that is our activity in Asia Pacific Biogas Alliance, mainly from Malaysia, some from Thailand, some from Philippines, and also from China and other country. In Asia Pacific room. We have Asia Pacific Gas Forum and other activity we are doing together. Next. That is our just for about Asosiasi Biogas Indonesia ABGI, Indonesian Biogas Association. There's some activity. The goal of this association is to develop further the biogas technology to be implemented in Indonesia. Next, we have also in the picture cooperation together with the European chamber, business chamber. Next. That is our, we have also the government, for example, for drafting of new regulation on renewable energy together with other renewable energy associations. Next, we hope the next we can get a good regulation win-win for both sides. Next, yes. Thank you. Next. Next, please. Next picture, please. Next slide. Okay. Yeah. I will introduce mainly for European participants about the potential biogas potential in Indonesia. The biggest feedstock is the palm oil mill effluent. We have in Indonesia about 875 palm oil mills, and now our calculation or our assumption is just about 70 palm biogas plant based of this POME. That means there's so many potential still potential application potential of biogas technology in Indonesia. We do not have just POME, but we have also other wastewater from other agro-industrial processing. Next. Yeah, this is another example. Besides POME, we have also cassava wastewater, and we have also a lot of empty fruit ponds. Optionally, we can also theoretically produce this as feedstock, use it as feedstock for biogas. But we need also pretreatment, special pretreatment for this. Next. We have another type of feedstock, namely organic waste from, for example, from municipal solid waste, also from traditional market, many vegetables and so on, and also other biomass, for example, water hyacinth. Next. Next, yes. Some example of development I mentioned before, that is our plan. This is the capacity of almost 1 megawatt electricity. Next, we try also use not only for not only for electricity production, but also for other purpose. For example, co-firing for boiler, steam production, and so on. These are another example of biogas plant in Indonesia. Many types of reactor, covered lagoon, tank reactor, and so on. Next. This is another example of a biogas plant, newborn. I call it newborn biogas plant. This just finished last year. This is not far from Jakarta. It's in Subang, West Java. Treat the manure, and yes, from Jakarta is not far. We can visit if we have time after Corona. Next. There's another example. There is a USB. The technology come from Belgium, I think, or actually from Netherlands, from Netherlands and Belgium. This is the company Christian Pineapple are happy having this investment because they can save a lot of money due to the subsistence of energy they use. They can use biogas to substitute the fuel oil and coal and gas for drying cassava, for processing of the pineapple, and so on. Next. This our not my but Indonesian project in biogas upgrading. I think that is the first one in Germany. So many hundreds of such upgrading unit. This is in Kalimantan or in Borneo. The processing capacity is raw biogas 500 meter cubic per hours. They use membrane separation technology, and they use also pretreatment to separate other gas like H2S and water and so on. They use the biomethane for internal use for their plantation vehicles. Next. This is also our just one example of our development, research and development, biogas from organic waste, from lab scale to a pilot scale in the field. This is in Lombok. is from Bali. If you visit Bali, you can visit Lombok, and you can visit this plant. Yes. Next. We can use the digester or the effluent of the biogas reactor for as fertilizer or land application. We can cultivate many useful vegetable and so on. And next, we can also use it for eco-tourism destination. Next. Yeah, I would like to just give future development needed or application, the potential we, as I mentioned before, not only POME, but we have also other solid material, solid waste, and so on. We need pre-treatment technology, and we can also use biogas not only for electricity production, but also upgrade it for fuel and so on. Next. Yeah, just some example of pre-treatment, mechanical pre-treatment, sand removal, fiber removal, and also thermal pressure hydraulics. Possibly, what this is what I did some 20, I think, some years ago, and also other chemical enzymatic, or also we can combine with mushroom cultivation and so on. Next. That is another technology. I know this from during my study. Developed many group in Germany developed the ultrasonic technology, mainly for disruption of for activated sludge from municipal wastewater from city. A city have a big wastewater treatment plant, and they produce also sludge that is content of microbes, and this microbe is organic and can be used as can be treated or converted to biogas. And we need ultrasonic to destroy the cell wall of the bacteria. Optional, we can also use it for POME to make to have better fluid dynamic characteristic of the POME. Next. Just some pictures from abroad, from Europe and from India and so on, just to give imagination about the utilization of biogas in form of biomethane or bio-GNG after biogas upgrading. Next. Yes, I visited 4 years ago the gas full station for the gas vehicle developed by a biogas farmer in near close to Stuttgart, supported by the government of Baden-Württemberg. Next. I visit also this plan. We would like also, I'm personally have the motivation to implement this technology in Indonesia, but I cannot do this alone, but we have to do this together with some other stakeholders. This is just example you utilize of biogas in form of biomethane injected in gas pipeline as city gas. Next. Yeah, we in Jakarta or around Jakarta, there's so many vehicles already already use gas as natural gas as fuel, and actually theoretically we can also, if we have biomethane, bio-GNG to replace this natural gas. Already the infrastructure is already there, and we can actually, if we can provide the bio-GNG, we can also use it for the vehicle. Next. Or we can sell as like GNG using the distribution system already practiced in for industry. Next. Or we can use also the household gas pipeline for household from this is mainly done by the Ministry for Energy and Mineral Resources. Next. Just two example of research and development in this direction. There is a group from ITB in Bandung that developed water scrubber technology to upgrade the biogas, to remove the CO2 and so on. Next. The next, that is the group from Gajah Mada University in Yogyakarta. They developed nanoporous carbon. We can use it as adsorbent. We can use, for example, as pressure swing adsorption, PSA. Next, or I think this the last. Yes, just one comment or some remark. That is also a big potential for technology provider in Europe. Please come to Indonesia. But one thing is that, for example, special for German technology, we know the German people have the principle of the high quality of technology product. But another side is the price a little bit higher than compared to others. So I would like to say or to give remark to especially to Frank Hoffman that it would be better if we can develop technology product in this case in biogas technology with a high quality but lower cost. That is, I think that we can also do, for example, the German company come to Indonesia with here the manufacturing, the fabric or manufacturing workshop in Indonesia. So we can try to lower the price, for example. Yes, this is my remark. I think we can discuss later if any. Thank you. Please, Pak Yudha.
Oh, I'm sorry, I forgot to unmute myself. So thank you, Pak Abdul.
You're welcome.
That is an interesting update on Indonesian biogas development, and it is nice to know that we have good collaboration with Europe already. And now we have several questions coming in, and let us open a Q&A session. There are a lot actually questions, but I will try to frame each of the question to more relevant questions. So first, probably it's more on the policy side. So this one is to Angela from IMAM, an independent researcher. As I understood, Europe's, especially Germany's, heavy use of renewable energy is supported by an excellent government policy. I think this may be difficult for Indonesia as the government has other priorities in their development agenda. Do you have any suggestion on making a government focus more on energy transition? This is probably relevant also to Abdul Holly. But first, I would like to respond from Angela. To you, Angela. You still muted yourself, Angela.
Sorry.
Yeah.
You hear me now?
Yes, I can.
Yeah. So as I mentioned in my intervention, of course, the support from the government is very useful. In Europe, we have different countries giving support schemes to the industry, and that helps the industry to cover the production cost. In the case of Indonesia, well, if I understood, I don't know very well the context, but I think that the government is currently subsidizing fossil fuels. So if the subsidies to fossil fuels could go to renewable energy instead, to help this renewable energy, in this case biogas, biomethane, cover the production cost, that would help a lot the industry to start developing. And well, for instance, I think the palm oil industry is very important in the region, and it would be useful to raise awareness to the government and to the stakeholders in general, that when we produce palm oil, we emit actually huge quantities of biomethane, which are lost. And this biomethane could be captured and put to use. So it's actually, this energy is already being produced, but it's lost. And it would be important to find a way to use the energy and avoid also at the same time the emissions to be released into the atmosphere. That could be an option to make it more interesting for the government, for instance.
Okay, thank you, Angela. And now, Dr. Abdul, can you respond to these same questions? Abdul? Okay, I think...
If you want to, I could add some additional points from the German perspective.
Sure, of course, fine.
May?
Okay.
Okay. I think in Germany we had somehow a similar situation like in Belgium, and 20 years ago it was similar discussed compared to Indonesia. What Angela said, it is somehow strange to support fossil fuels and to say renewable energies, now you can go on the market, but only if you are cheaper compared to fossil fuels. That's an unfair game. So it's a very important point for the government to write this, to have a good incentive system and to steer the development in the direction they want to do it. What was a very important point for European stakeholders were job creation. For example, with biogas plants, we have about 10 jobs per megawatt installed capacity, much more compared to fossil fuels, for example. What was very important for us to convince the government is if a country spends money for fuel, for example, for coal, the money is burned and going away out of the country. The money for renewable energy is circulating. it might be that it seems to be that renewable energies are a little bit more expensive compared to fossil fuels. But if you think that the money is creating jobs internally and is creation value is not burned, that's a huge argument, at least for the German government, and I think nearly all European governments. And an additional aspect is being independent from imports of fossil fuels. That is very important for Europe. For example, we are getting a lot of gas from Russia and from Northern Africa, so we want to get more independent. But above all, of course, fighting against the climate crisis, that's the main motivation, and each country should contribute to that main challenge for humankind, let's say it like this. And for that, we hope that more and more governments understand that renewable energies are the future. Fossil energies were the past. Thank you.
Okay, thank you, Frank and Angela. Now we'll have to move on to the second question. This one is from Mr. Iqbal Yulizam Mufti from Kota Hidup Institute, and also it has several questions has the same topic or issue. I see here from Eri ITB, and also from Yudha Salaras of Hijau, Indonesia. It's related to the application of biogas technology in urban settings. So what are the main criteria or also some hurdles or difficulties for biogas technology to be implemented successfully in urban settings in Indonesia? So probably this one can be answered by Pak Kholiq. Pak Abdul Holly, is he? Oh, I think it's offline, yeah? Okay, so probably we will take these questions to Frank. First, probably, is there any implementation of urban biogas technology application in urban areas in Germany? Probably they already are. Can you share some information on that?
Yeah, some general words about biogas projects. What are the main challenges? From technical side, it's the feedstock. So mainly, nearly each biogas project starts with the feedstock. If someone from the industry or from municipalities identifies that they have huge amounts of feedstock, that might be a chance to think about or start to think about biogas installation. The next challenge, of course, is economic calculation to think about what might be income streams. And I will say some words about that in some minutes in my presentation. When we are talking about waste, the main challenge might be the quality of the waste. So what goes into a biogas plant will go out and should be used as fertilizer. In terms of waste treatment, the quality of waste is the main important aspect. If we are thinking about waste treatment, for example, in a big Indonesian city like Jakarta or their Bandung, then the collected waste usually has several kinds of qualities. Plastic is not good for the biogas plant, wooden things or metals. So at least in Germany, from the European perspective, the pre-separation of waste streams into a good quality organic waste stream source, that's the main important point, usually done upfront. But there are several technologies to deal with wastes. That's it from my side. Now I see that Mr. Abdul is online again.
Okay, Pa Abdul, there's this question related to difficulties in implementing biogas technology in urban settings. What's your take on this?
First of all, biogas technology is not difficult. That is natural process, but The problem is we have to maximize the biogas production, for example. I know, but there's some limitation in rural area concerning the human resource, the capacity of the human resource. For example, the how the people paid the biogas plant properly, and how to operate the biogas plant properly. We have to increase the level, the human resource capacity. We have to do capacity building much more. That is, I think, the biggest problem that we have to solve.
Okay,
but technically, there's no. I think if there's technically that is not difficult if there's so many biogas provider, the biodigester provider. They know how the biogas digester is, but we have to give the people some basic knowledge and basic skill to operate and so on.
Okay, there's only one question left for the time that we have for Abdul. I will take this one because we only have about 4 minutes. So Abdul, this is a question for you. What do you think is the main challenge to apply bigger utilization of biogas in Indonesia? Is it because of coal electricity is still much easier and cheaper to get?
Yes, but another side, we have also another advantage of biogas. Biogas not only energy production, but at the same time, we treat also waste or wastewater, which is not good for the environment. What I mean is, we should also further support the biogas technology to be implemented, not only for electricity. Yeah, I know there's some difficulties in this business because there's another some years ago there's a change in philosophy of electricity business in Indonesia. Now we would like to give electricity as much as possible, as cheap as possible, and that's why we have also we have to try to decrease the production cost of electricity from the biogas. That is a big challenge, but we are in association. We would like to give alternatives utilization.
Okay, I think Abdul is having another trouble with the internet, but I think we get the point from what he speak about the. Oh, now he is again. Can you hear us, Abdul?
Yeah, I'm sorry. I think I've difficulties in the internet connection. My Wi-Fi is.
So probably you want to finish your explanation.
Okay.
We have about 1 minute.
Yeah. There was a regulation not so encourage the electricity from biogas. For example, the BOOT transferred after that to the plant have to be transferred to the PLN, the electricity company, state-owned company. But in the new regulation, we hope there will be a better condition.
Okay, so thank you, Pa Abdul Holly. And with that, I'm afraid we are come to the end of session 1. So I would like to take some key takeaways from here. So probably I will have 4. Indonesian biogas potential is very huge. From the slide, we can see that Rio maybe is the main source for biogas production, but we also can see that there are still many locations which are quite potential for biogas implementation, including some implementation of biogas production and distribution in urban setting or in cities. Some biogas technologies have already implemented in Indonesia, and they saw success in many cases. And so the potential biogas in Indonesia is open for opportunity for proven biogas technologies. But as Abdul Holly said, it should be at an affordable price for Indonesia. And Indonesia needs to put more effort in developing supportive renewable energy policies, and it should take into account economic and social aspects, for example, employment, because it really can support biogas development in Indonesia. And that's the key takeaway from the first sessions. And now we will move on to the seconds. So I would like to thank you first to Bapak Abdul Holly and also to Angela for your presentations. In session 2, we will have Frank. And let me introduce Frank Hoffman first. Frank Hoffman is with the Department of International Affairs at the German Biogas Association. He studied energy and process engineering at the Technical University of Berlin. Also, he is a graduated consultant for biotechnological applications with 22 years experience on biogas topics, including the design and planning of biogas plants, research on upgrading of biogas, and fit-in of biogas into the gas grid. In DBFZ Institute, he is also a bioenergy consultant of Ecofis Germany and also conducts biogas feasibility studies and biomass and biogas lectures. So let's just invite Frank Hoffman. To you, Frank.
Yes, I can hear you. Good morning from Europe. Good afternoon to Indonesia. Yeah, that's my first slide. Yeah, I'm very glad that I'm invited to join this webinar. What we will do in the next minutes is I will show you some information about typical European biogas technology. In the end, in DiBiCoo, we want to create the connection between Indonesia and Europe. In the next half an hour, you will get some examples and some typical pictures from European biogas technology. The next slide, please. That's the program. I will first introduce my association. We'll explain a little bit the motivation for biogas projects. We already mentioned that what's the main challenge? Why should someone invest in biogas plant? We will come to the biogas technology overview, and I will end in the end with some project examples. The next slide, please. Just some words about the association I'm working for. The German Biogas Association is probably, let's say, the biggest biogas association in the world. We have 4,700 members. Most of them are operators of biogas plant. By the way, we have about 9,500 industrial-sized biogas plants in operation in Germany, and nearly half or a third of all operators are organized in our association. We have companies, technology manufacturers as our members, and from the salary from all these members, we have the salary from the fee, membership fees, we have the salaries for 40 employees, which are working for the German Biogas Association. The main objective is working on legal frameworks, doing political advocating, developing technical standards, exchange of information. That's the part which I'm doing now. And I think that's, in short, the main important points about the German Biogas Association. The next slide, please. Some people in the chat already mentioned what is the main motivation? Why should we, or should someone think about biogas? Well, I'm working often in international contexts, from Africa to Caribbeans, whatever. And these are the main answers I usually get on these questions. One is decentralized energy solutions. With biogas, we could produce electricity, heat, transportation fuel. I will come to those technology utilization paths in some minutes again. In some regions, even avoiding blackouts and is very important. That's probably more in Africa. I don't know if there are very remote islands in Indonesia, for example, how stable is the grid. Avoiding blackout is very often heard in Africa, or avoiding or reducing high costs from importing fossil fuels. I think in Indonesia, many fuels or forms of energy are subsidized. But if I think about landing oil, for example, at the harbor, but that's cheap. But transporting the oil for vehicles, for example, of hundreds of kilometers within the land, that's costly. And to produce energy on the location, that might be a chance as well for motivation for biogas projects. Some motivations are regulations from the environment. For example, wastewater. In past times, it was very often from the industry pumped into the rivers. That's more and more forbidden. So the industry, or who is producing wastewater, is usually responsible to treat this waste. I think in Indonesia, for the palm oil mill effluents, it's very important to have reduction of methane emissions from open lagoons, for example. So the environmental regulations on that might be important as well. And it will be becoming more and more important when we are talking about or thinking about municipal waste. Of course, it's cheaper to dump waste on a landfill or an open dump, but that will not be the future. The future will be that we are so many people in this world that we have to care how to use resources and to avoid landfills, for example. So municipal waste treatment might be one important motivation for biogas plants. The next point, we already mentioned it a little bit in Europe. Oh no, not the next slide, back. Yes, thank you. In Europe, we have several kind of incentive systems: feed-in tariffs, quotas, tenders, reduction of tariffs or taxes. That were the instruments which are very often a driver for a biogas project. The main important point is, of course, to get good economy for a biogas project. These kind of incentive system can really help to push the market. Other motivations might be greenhouse gas emission reduction, carbon certificates. We will come to a project which is at least to half of the income streams were created by carbon certificates. I will come to that later. Fertilizer production and waste process water treatment, that are some additional motivations. And that, in short, are the main motivations for biogas projects. The next slide, please. Here we see an overview about different kind of technologies. I will not go into the details now, but I just want to show you how wide the spectrum is biogas can be produced. It could be from the left-hand side, typically stirred tank digesters. We already saw some pictures in the other presentation. Could be lagoon digesters. I will focus on those kind of technologies in some minutes. Sewage sludge could be treated or digested, and their home or domestic digester system. I will not talk in this presentation about home digester systems or landfill gas utilization, because the DiBiCoo project is focusing on industrial biogas plants. And having said that, we come to the next slide. Next slide, please. These are typical examples of biogas plants at industrial sized. On the top, on the left-hand side, that are typical agricultural biogas plants. In the middle picture on the right-hand side, we see a waste treatment plant, which is usually using sorted household wastes, markets, restaurant residues. You see in the bins, there are expired foodstuffs, bread, yogurt, meat. All these materials can be digested. And there are special adapted industrial sized biogas plants for breweries, sugar industry, for example. Next slide. The feedstock could be organic municipal waste or bio-waste at household level. Industrial commercial waste is a very huge and promising potential in Indonesia as palm oil mill industry. But if you think about any kind of food processing industry, that might be a good chance to start a biogas plant. When we are thinking about agricultural animal byproducts, manure is a typical input material for biogas plants or vegetable byproducts. For example, during a harvest, not all fruits can be sold. Usually there's some quality which is not the best, and that could be used for biogas plants, or even the leaves of the fruits. Sometimes it's half of the mass. The leaves which cannot be sold on the market could be used for a biogas plant as byproduct. Next slide. Important for the next slide, yes, that's the right one, is the type of technologies. There are very different kind of technologies developed and available on the market. In this slide, you see from the left-hand side, if the dry matter content is 0, that's pure water, 100% pure water. On the right-hand side, we see on the scale 50% organic dry matter, which means half of the material is water, half is organic material. And depending on the amount of water or the dry matter content, there are different kind of technologies adapted to the feedstock, or the feedstock and the technology should go hand in hand. On the left-hand side, we can start with lagoon biogas plants, wet digestion. When we are coming to the middle, we have dry continuous digestion, or 30% upwards dry batch digestion, or even composting. I will go in some minutes into this kind of technologies, but with this slide, I would like to show you the overview that the best technology is mainly depending on the quality of the feedstock. Let's come to the next slide. Most often used are continuously stirred tank reactor. In Indonesia, it's lagoons. I will come to that in a minute. But in Europe, the typical technology is completely stirred tank reactors. Here you see some components. Usually it's a tank, several hundred cubic meters big, mainly made of concrete, sometimes from steel. There's usually an agitator and mixer in that. On European conditions, it's good to have a heating system. It's very cold in the winter time. In Indonesia, I will come to that. If you need a heating system, heating up the material is, let's say, better, or it speeds up the process. The bacteria inside the digesters feel best at the temperature of about 37, 40 degrees. And that's why many biogas plants are heated up. Very often on the rooftop of such a digester is a gas storage. The biogas itself is produced in the liquid. The tank is filled up with liquid, and you see the brown graph, part of the graph is liquid. Biogas is produced there, goes up to the top, and there's a gas storage, often on the rooftop, but could be besides as well. The next slide. That's a typical look into the reality, how it looks like. Digester made of concrete. On the bottom floor, you see the pipes for the heating. Very robust agitation system. Mixer is very important because it has a lot of mechanical stress. It must be very well designed. On the rooftop, we see a wooden construction where some bacteria could settle to reduce H2S. And above that will be the gas storage. Next slide. I already mentioned most of the characteristics. Usually with continuously stirred tank reactors, we have a continuous feeding or near quasi-continuous, maybe 6 or 12 feedings per day. Feedstock can be used nearly any kind of quality we can think of. The typical dry matter content ranges between 6 and 15%. Feedstock should be pumpable. Agitation is usually done, it's necessary to avoid sinking layers, to avoid swimming layers, to bring the feedstock together with the bacteria. Temperature can be about 37-40 degrees mesophilic, but it can be operated thermophilic as well. And that's the main important point. Maybe we can come to the next slide. We come to the next technology, that's plug flow digester. So a different kind of technology solutions. The input is from the left-hand side, where the material is pumped into this kind of digester. There's a very robust stirring system in such a digester, and the flow of the material is going from the left-hand side to the right-hand side. By that, we have an, let's say, quasi-ensured retention time. Usually it's calculated in a way that from left-hand side to the right-hand side, the material will need about 20 to 40 days, depending on the quality of the feedstock. These kind of plug flow digesters are usually heated up as well. And the biogas is produced in this liquid material, which is stirred and pumped up from the top. Next slide. Characteristics, the dry matter content is usually a little bit higher. Here we see the typical values are 15 to 45% dry matter. We have a continuously feeding. Agitator is very important because if you think about such a system, it needs a really robust agitation to push the material through the digester. Often the temperature is thermophilic, but mesophilic is possible as well. And this kind of plug flow digester can be constructed in a horizontal or vertical way. Usually there's a limit to the reactor volume, about 1,000 to 2,000 cubic meters. Completely stirred tank reactor, which we had before, can sometimes be created even or constructed in a bigger way. The plug flow digester size is usually a little bit limited by mechanical stress. Having said that, we can come to the next slide. That's a picture from inside that you get an impression about the robustness and the stability of such a stirring system. It really has huge mechanical stress, and it should be created in a way that such a stirring system will at least hold reliable for 8 to 10 years. Then usually it is exchanged, but that's a key picture from side of a plug flow digester. Next slide, please. We come to a very different kind of technology. That's a garage system or dry batch reactors. It is constructed in a way of a garage. You see it here in the middle of this picture. The door is opened and the material is brought into such a garage system by a wheel loader, for example. After a while, or after filling it up, the door of the garage is closed. And within this garage system, bacteria and feedstock are brought together to create biogas to digest the feedstock. What is important is that during the digestion, there will be water flowing out of that because the cells are broken up. The water is collected, you see it here in a drainage system at the bottom, pumped into a second digester, which is called percolation system. And from this percolation system, the water is spread into the garage as well to bring the water and the bacteria to the feedstock. This kind of percolation is an important point of that. And about half of the gas is produced itself in the garage. About half of the gas is produced in the percolation tank. The next slide, please. And that's how it looks in reality. So we have huge garage systems of several, sometimes hundreds cubic meters, doors open, filled in, doors closed after a while, is closed. And then the typical retention time is about 1 month, about 4 weeks time, the door is closed. And after a while, it can be opened again at that time when the most of the material is digested. Next slide. Here are the characteristics. So we have a discontinuously feeding about every 4 weeks. The feedstock can be much drier, 30% or even above. Sometimes it's stakeable, not pumpable, stakeable. We have no agitation. That's good from the, let's say, maintenance aspect, because if there are no agitators, no moving parts in the reactor itself, it is quite robust. Typical process temperature is mesophilic. And other characteristics, new, fresh incoming material is usually mixed with already digested material. So if the garage is emptied and refilled, usually a part of the feedstock, about a third or fourth of it is remaining in the garage and mixed up with fresh material, again, to bring bacteria and feedstock together. Percolation system, I already mentioned that this is an important point. Next slide, please. We come to the next technology that's typical for Indonesia. I think most of the biogas plants in Indonesia are lagoon digesters, usually using lagoon from wastewater industry, palm oil mill effluents. That's very typical. And this is somehow a graph from a lagoon digester. We should have membrane or plastic material on the ground to avoid leakages to the ground. And of course, we have the cover, a membrane cover for gas storage. And this is somehow a very simple way to create a relatively cheap or not too expensive biogas plant. Mr. Abdul mentioned already that European technology is usually high priced. Sometimes it is, yes, but it's reliable. It's usually biogas plants are working reliable for 20 years. These kind of lagoons are more not so expensive solutions, but we will come to some advantages and disadvantages in some minutes. Next slide, please. Mr. Abdul already showed some pictures. Here's another pictures just to give you a visual impression. This is from Middle America. Oh, now I see that my battery is close. I'm back in a minute. My battery is very close. Sorry, I'm back. I saw just the warning that the battery was low. Okay, let's continue. The next slide, please. The characteristics. Typically, the material flow is always almost continuously. The residues of the industrial production before that are pumped in nearly continuously. Usually lagoon digesters are huge. Typically hydraulic retention times are about 100 days, even bigger, depending on the, let's say, size of the lagoon, of course. Smaller lagoons or hydraulic retention times are possible, but then we come to the next points, which might hinder smaller retention times. Well, the next point is feedstock. The water content is very high. Dry matter is about 1 to 8% usually. And open lagoon digesters are very often used for processed water. Palm oil mill effluents, we already had that. Agitation is a challenge because there are huge volumes, much water, and agitation would need a lot of electricity. Sometimes a little agitation is done by pumping in the material in a way to agitate the volumes, but practice shows that lagoon digesters very often have the problem of sinking layers. By sinking layers, the, let's say, active volume is reduced, and after a while, typically lagoons are shut down for a while, and the material has to be taken out, which needs a lot of time, and so that's a problem to have less opportunities for agitation. Process temperature is usually ambient temperature. In Indonesia, that's usually okay to get enough biogas, but I come back to the point of the hydraulic retention time and the temperature. So the higher the temperature is, the more active are the bacteria inside the digester. And if we are talking about a biogas plant with ambient temperature, 25 degrees, for example, sometimes 30 degrees, the bacteria activity is not optimal. It is working, but it's not so active as it could be. And that's why the hydraulic retention time should be longer to get a good biogas yield. If the hydraulic retention time would be very short, 20 degrees, and the temperature is low, then the biogas yields would be low. Here, the lagoons making a compromise between temperature and the hydraulic retention time. And that's different to completely stirred tank reactors. Those are usually insulated and equipped with a heating system. And that's why the hydraulic retention time in completely stirred tank reactors usually can be reduced. So an engineer will find the best compromise between that. The volumes are usually huge, 1,000, 20,000 cubic meters. So there's no very limit to the volumes. Maybe the next slide. So the advantages are lower investment cost, relatively simple technology, high retention time, which results in a stable process. The downsides are lower biogas yields, relatively low process control, and agitation is a challenge. Safety issues, I don't know exactly in Indonesia what's the status about that, but I heard from Thailand that they had huge problems with the safety of lagoon digesters, huge surfaces of membranes. So if there are heavy weathers, rainy season or storms, some membranes were blown away or even huge accidents with that. So the safety issue is an important point considering lagoon digesters. It's a good technology, but we really want to stress that it's important that those technologies are constructed, that the operation can be done in a safe way. Next slide, please.
Excuse me, Frank, you have about 5 minutes.
Okay.
Thank you.
The one option for biogas is biomethane. Mr. Abdul already mentioned that. Here we see the characteristic of biogas, usually 50 to 70%, and carbon dioxide 30 to 45%. If we separate methane and carbon dioxide, then we can reach nearly pure biomethane. 97% or even higher is possible. If we are talking about pure methane, then this pure methane can be used in all streams like natural gas is used. The next slide. So natural gas or biomethane can be used for electricity, heat, or vehicle fuel, can be injected into the gas grid. Here we have a pure chemical material. Next slide. But there's additional investment needed for the additional investment for the equipment that usually is economically feasible only for high volume rates. So the typical size of a biogas upgrading plant is about 500 cubic meters per hour. I think in Indonesia, these kind of biogas production rates should be even higher, but it's possible for big lagoon plants. But we should have in mind not all biogas plants will be equipped with a biogas upgrading system, only the bigger one. Next slide. There are several technologies on the market. Due to limit of time, I will not go into the details of these, but here you see an overview about at least that there are several technologies on the market, and the choice of the right technology is depending on the gas quality and the volume rate mainly, and some other conditions on the location. Having said that, you can skip this slide and going to the next slide. And next slide, because I already mentioned how to use the gas. Next slide. Use it for electricity, heat, natural gas. And at the end of this presentation, I will come to a project example in, let's say, the region at least of Indonesia. I didn't have an example of Indonesia, but this is in the Philippines, and maybe some similarities between Indonesia and Philippines can be seen here. This is a biogas plant created by the company LIP. Next slide. In Indonesia. The interesting thing is that it's working with the residues of pineapples. You see it here. There's a pineapple plantation. These are the residues, and those are used for the biogas plant. 2/3 of the gas is used in the boiler, 5,300 kilowatt thermic, and 1/3 of the gas is used to produce electricity and heat. The gas energy is used on the location itself for the pineapple production or pineapple cannery. Next slide. There are several digesters, one pre-digester before the main process, 2 main digesters, and 1 post-digester. You see the pre-digester has a volume of 3,000 cubic meters. Next slide. That's a picture of the main digester. You see the dimension, that's huge, 8,300 cubic meters, made of steel. You see the rooftop construction and the main tank. Next slide. And a post digester, which has a volume of 600 cubic meters. Next slide. And that's mainly, the end of this presentation. I will make a very short summary, or maybe we come to the summary later. It's up to just very short summary. Biogas plant is nothing new. It's a well-equipped state-of-the-art technology. When we are talking sometimes in developing countries, the banks are skeptical. Oh, that's new technology. Is it reliable? We have more than 80,000 biogas plants in operation in Europe, so it is reliable. We have decades of experiences in Germany, 20, 30 years of experiences. There are several technologies on the market. The main value comes usually from energy or carbon certificates. The example from the Philippines was at least to half financed by carbon certificates. Fertilizer, it's a huge value. The effluent of a biogas plant contains all the minerals. Wastewater treatment might be an option for revenues. Some biogas plants which are treating waste are getting a gate fee for waste treatment. They are mainly financed by this gate fee for waste treatment. And biogas can be used for electricity, heat, and transportation. And that's my presentation. Thank you very much for the attention. Maybe yes, you can show the last slide for the people who are interested to get more into the details. We have some information material available about bio-waste treatment, biogas to biomethane, the value of digestate, and about fertilizer. Thank you very much for your attention.
Okay, thank you, Frank. As we can see that at least from the Germany side alone, there are various technologies already available for various conditions of feedstocks and the environment and technological levels. Also for different requirements of the location. And now let us come to the Q&A session for session 2. We have several questions here. I will try first to take this question related to CNG. This one is from, it is not mentioned from whom, but I will take these two first. To Frank, biogas for CNG has so many advantages, but in Germany, how many % of biogas will be mixed to the CNG? And the second question related to CNG from Agus and A.B. Hart, can compressed biogas compete with CNG? So these are the two questions, Frank.
Mm-hmm. Okay, so first about the share of the biogas upgrading and the uses for CHP in Germany. About, I think it's 4% only of the produced biogas is used as CNG. The main reason is our incentive system that we have in Germany, that in the past years it was more economic interesting to produce electricity. CNG is possible, but it was a little bit less attractive. It will become more attractive in the future because the prices for a renewable energy quota will rise, and probably in the future much biogas will be used as CNG. But on the other hand, that's mainly depending on the incentive system. If we are looking in Europe, for example, to Sweden, there most of the biogas is upgraded to biomethane and used as CNG. So if the share of biogas and or the relationship between biogas and CNG is much depending on the local situation, on the incentive system, both is possible. Angela mentioned about 700 biogas upgrading systems are in Europe. If you bring this into relationship with 18,000 biogas plants in operation, you get an impression of the amount of CNG. The other question was using CNG or biogas. I know that there are some developments to think about why can I not use biogas directly, not upgraded in CNG compressed gas cylinders. That is somehow a little bit more problematic. The CNG gas cylinders, according to, let's say, industrial standards, usually have 200, 250 bars. And that's why the purity of the gas is very important. If we would compress biogas, methane and carbon dioxide to 250 bars, carbon dioxide might condense. That's a problem. And let's say there's much pressure in such a gas system. Of course, there are options to have a lower compressed gas system. That biogas, for example, is just compressed to 10 bars filled up in bottle. That's possible, but then there's a negative aspect that the energy density in the compressed gas cylinder is low, not much energy in that. So the European way is usually pure biogas to biomethane quality, compress only the methane to 200 bars or 250 bars and use that as compressed gas cylinder, which can be handled in cars, in trains, in several other, for trucks, for example. That's a typical way.
Okay, thank you for the explanation, Frank. We will now take the second question. This is actually from Mr. Fajar Muni of PT Cipta Visi Sina Bencana. It is addressed to Frank and also Angela. Question is, how do biogas practitioners in Europe tackle the challenges to apply bigger utilization biogas? Oh, this is almost the same as the previous question. How the European tackle the challenges to apply bigger utilization biogas while the coal electricity price is still easier and cheaper? What is the key success factor to engage EU government to do this? So I think I will go to Frank first and then to Angela.
I don't know exactly if I understood the question right. Maybe you can correct me, but I understood why is it biogas more used for electricity and not so much for CNG? I can answer on that.
The question is how the European practitioners tackle the challenges to apply bigger utilization of biogas. So you use a lot more biogas, while actually the coal electricity price is still easier and cheaper. And how do they do this?
I think that's steered maybe mainly by the government. For example, in Europe or in Germany, and Angela can explain for the Europe side, we have feed-in tariffs, which are very attractive. Feed-in tariffs for the connection of a biogas system or a renewable energy system with the electricity grid. We have very attractive tariffs for that. The tariffs are now between 14 and 20 cents per kilowatt hour, which is very attractive for the biogas plant operator. And it's made in a way that the economic or that there's a creation of business cases without good or the feed-in tariff is made in a way that biogas projects, electricity production is profitable, set by the government, the feed-in tariff, the height of it, and that's why many investors are interested to go into that business. The, let's say, price for electricity is fixed by the government, and that's our kind of successful system.
Okay, Angela, you have a take on this?
Yeah, maybe. Well, I can just add to this that it's important to understand that in the case of Europe, the government is really, the different governments are aware that it is important to provide an environmental benefit, that we really need to reduce emissions because we need to leave a better future to the next generations. And this is leading to the government taking the initiative to implement policies that will help develop renewable energy. And in the case of biogas, biomethane, the support schemes are being very useful to provide a level playing field so that any renewable energy can compete with fossil fuels. Coal, of course, is cheap, but is the most emitter of emissions. So that is not an alternative in Europe. We are really phasing out coal. And another reason, apart from the environmental benefits, is that we want to, I think it was mentioned already by Frank, to become independent from fossil fuels imports. So, well, these are two very important drivers in the case of Europe, and the support schemes that are more popular within the different European countries is the feed-in tariff that Frank mentioned as well. If we want to engage the governments also in Indonesia, apart from, well, providing support, it's important to mention that biogas, biomethane, it's a renewable energy that can be produced locally. It has an advantage compared to wind and solar because it is flexible and it can be easily stored, and it produces energy all the time, whereas wind and energy are intermittent. So the energy is produced when there's wind or there is sun. And there are other environmental benefits that we mentioned as well, for instance, for agriculture. And we can also really help reduce pollution in cities, air pollution, which is also quite important problem in Indonesia. I think we can create local jobs. We can use the existing gas infrastructure if we upgrade to biomethane. So we have many important benefits that we should really take as positive and inform the government, raise awareness about all these benefits.
Thank you, Angela. And so thank you, Frank. We will move on to the next questions. This one is actually for Pa Abdul. This is from, okay, it doesn't mention from whom, but this is the question. How is the relations between waste producing companies, such as palm waste producers, with the Indonesian government and the Indonesian Biogas Association? Pa Abdul?
Okay, palm oil producer is palm oil mills. Government, BBTs belong to government. We can give them technology services. For example, if they need technology solution, they can contact us via under the government. Another government are mainly the ministries, for example, the Ministry for Environment and Forestry. They do, for example, the grading, how environmental friendly are the companies, the palm oil mill producer or the waste producer. In this case, they can give the green or red or black and so on. That is image of the company to the society and so on. Another thing is from the Ministry for Environmental and Forestry. They have, as I think, regulation that the company have to treat the waste or the wastewater. So in this case of waste or wastewater with high contents of organic, the best way I think is the biogas technology, because you treat at the same time you produce energy. And another ministry, I think the Ministry for Energy and Mineral Resource. If they produce energy, maybe they can contact this ministry to get advice and so on. For example, if they would like to put a biogas plant, and at the end they will sell electricity for the government, they have to contact, I think, the ministry. Another thing, I think the agricultural ministry for the cultivation, but not so directly related to us, but they can also use the digester or the effluent of the biogas digester as fertilizer. And to associate to ABGI, Biogas Indonesia Biogas Association, some of the some people from the company, so from such company, are joining us as members, as also some of them in the committee of pengurus Asosiasi Biogas Indonesia. I think we can give service if they need help from us, but we can also give service to them, to all, not only for the members. Service in as, for example, information, technology update, and so on. That is my answer.
Okay, thank you, Pa Abdul, for your answer. Next question is from Danny to Angela. Is there any opportunity biogas project in Indonesia financed by EBA?
Well, EBA, as EBA, we don't finance projects directly. We are involved in European projects, including this one. And well, in general, our scope is more Europe. In this case of DiBiCoo, it's the contact between, or the link between Europe and other regions at global level. But of course, in DiBiCoo, what we promote is the export of European technologies because they are good quality and they are safe. And it is very important if we want to achieve good results in terms of plant operation or good social and environmental benefits, that we use the right technologies with good quality.
Okay, thank you, Angela. And we have about 5 more minutes for the question and answer sessions. We have the last question here for Bapak Abdul. Abdul, can we use electricity from biogas directly without PLN, without a state electricity company? And can we sell the gas to the other industry directly if we have overstock of gas? So it's also from Danny.
Yeah, in principle, if you would like to sell the electricity, you have to sell to PLN as electric company. But I think there's some exception. For example, if there are no PLN if there no PLN operation in there, for example, in very rural area, I think you can organize such cooperation or something like that. Company belong to the village, BUMDES, for example, and you can sell the electricity for the people. As example is the electricity from biomass power plant. I know there's some project, some power plant from biomass power plant, and they organize with the cooperation of BUMDES, and they sell to the people in the village. And I think internal use is also another possibility. I don't know, maybe there's a regulation or not. And selling the gas, I think now is no regulation yet for bio-GNG, but I think they will be regulated as GNG because that's more or less the same. But we hope that that in the next future, if the bio-GNG coming, there should not be what I mean is they should let them grow first, not regulated as GNG because maybe they have to fight first for the market. Let them grow, have the market, and but in the regulation, in case of safety, we have to implement this actually, naturally, in principle, because it's the basic of the if you not care about the safety, forget it. That means regulation in terms of safety regulation we have to consider. That is my opinion, but we can ask the colleague friend from the Ministry for Energy and Mineral Resource. Okay, thank you.
Okay, thank you, Pa Abdul, for your response. And that concludes our Q&A session for the second session. And I would like to deliver some key points or some key takeaways from this. First, Germany is likely to be the leader of biogas technology. A wide range of biotechnologies from Germany is waiting for opportunities as long as the technology fits the locations and the feedstocks and also other requirements or criteria of a country. The main criteria for biogas technology adoption is probably the feedstock availability and also sustainability. And especially for urban settings, especially the quality of the feedstock is very important. Risk and safety also are important aspects to consider in biogas technology implementations, aside from profitability or environmental concerns. And again, one more time, supportive policy is very important to boost biogas development, at least in Indonesia. So we as biogas practitioners and also biogas academics need to raise the awareness of biogas technology more and show the importance benefit of biogas to the country. So with that, we end the session 2. I would like to thank you, Frank Hoffman from the German Biogas Association, Angela Sainz from the European Biogas Association, and also Abdul Holly from Indonesian Biogas Association. And with that, I would like to return the webinar to Mr. Isham. To you, Mr. Isham.
Okay, thank you, Pak Yudha, for moderating the webinar session. And also, I would like to say a sincere thank you to all of the speakers involved in this webinar. And I would like to also inform you that this webinar is funded by the European Union under the Digital Biogas Global Cooperation Project, which is the DiBiCoo. As presented in the opening session previously, we are offering free of charge services for capacity building, training, and also coordination between biogas developers in Indonesia with European stakeholders. And also, most importantly, as shown in the screen right now, we also offer free of charge services for biogas projects pre-feasibility study, including revenue analysis and technical analysis through the development of a technical concept. So you can register your project ideas in the link now shown in the screen right now. And then we are also welcoming your contacts through the link that has been provided in the chat, the live chat feature. And also the deadline for the submission of biogas projects is due for 31st of July 2020. This has been recently extended due to the current health crisis happening around the globe. And I would like to also highlight that DiBiCoo also provides a technological solution through a software platform which connects stakeholders from developing countries, including Indonesia, with stakeholders in the biogas industry from Europe. You can also gain access to this prototype information system, as we call it, under the DiBiCoo project. You can gain access of it through contacting us by dropping your email in the link provided in the live chat as previously stated. So I would like to once again thank you for everyone that has presented and also those that has allocated their time to attend this webinar. If you have any further questions on DiBiCoo or you would like to get the presentation materials from the webinar, you can gladly drop your contact in the link. So I'd like to say thank you for everyone again, and we will now end the session. Thank you very much.